Now moving further, once we got term frequency, what's the next thing that we can do? Actually get inverse document frequency. And how do you actually get that? Simply, if there is, let's say, a text word like Gotham, and we need to get the inverse document frequency of that, what we need to do is, out of all the 3379 movie plots, we just need to see in how many movie plots does the word Gotham occur. And how can we do that? Basically, we calculated this column, and from this column, as you have dictionary here, you can get all the keywords that are here. So basically we calculated this column TF, which essentially captures all the unique words, and all we need to do is iterate through all the keys in this dictionary and see if our word is present in this or not. That's exactly what we are doing here. If the text word is present in the row tf.keys, we are just incrementing the counter, and wherever it is present, we are printing that movie name and Wikipedia link as well for sanity check. Let's run this. So what this simply means is that out of all the 3379 movie plots, the word Gotham is present in these 7 movie plots: Batman Begins, Batman vs. Dracula, Dark Knight, Birds of Prey, etc. Sounds good. So how do we get document frequency? Document frequency is nothing but 7 divided by 3379. That is how many times a given word occurs divided by the total number of documents. So here we are just doing that, which is the document frequency of the word Gotham is 0.002. And as we have already seen, a keyword is something that occurs frequently within a document and that is rare across the documents, which means the term frequency of a word should be high and the document frequency should be low, and the inverse of document frequency is basically IDF, inverse document frequency, and we are getting that here. So in order to calculate the importance of the word, all we do is basically multiply term frequency with 1 divided by document frequency, or term frequency into inverse document frequency. That's what we would do, and this is exactly what we are doing. We got our inverse document frequency for the word Gotham here, and you know how the modified value is, right? There is a +1 at the top and bottom to avoid divide by 0 errors, etc. And at the end of the day, again we apply logarithm to this. So we are just seeing how the logarithm works. As you can see, for 10,000 as well, it is just 4, and since we have 422.5, this is the IDF. So at the end of the day, the IDF for the word Gotham in our document is 3.625. And what we are doing here is nothing too complex. Given any word and the full data frame, we are getting the inverse document frequency of that word. So whatever we have seen above, I've just kept that into one single function. Now, how does this help? Basically, we created 2 functions. One function to get term frequency and the second function to calculate inverse document frequency. And simply, if you just combine these 2 things and just multiply term frequency with inverse document frequency for every word, you can put these functions together and just create a library. A library is nothing but a collection of functions that work towards a common task. Here, extracting TF-IDF or word importance. So what we are doing here is basically, given any word, you can calculate the inverse document frequency by passing the total corpus as well as the word. That's what we are doing here, and we get the inverse document frequency of the word Gotham. Now let's combine both of these things together, which is we are getting our Batman Begins TF dictionary from this, and we are getting for the word Gotham the term frequency, and we have already got the inverse document frequency of the word Gotham. Now simply in the movie Batman Begins, we are calculating the term frequency multiplied by inverse document frequency, the TF-IDF for the word Gotham, and that is just the multiplication of the above two calculated values. So we got the TF-IDF for the word Gotham in this movie plot across the corpus, and simply you can extend these functions that we created and you can just calculate TF-IDF vector for the whole movie plot of Batman Begins. Now the power of this is that with a single algorithm like TF-IDF, you can extract keywords from any given document. How do you extract keywords? So basically, whichever words have the highest TF-IDF value, if you just sort the words in a given movie plot by their TF-IDF values in decreasing order, you extract keywords. And you can retrieve similar documents as well, because you can create a unique vector for each movie plot, and you can compare those vectors among each other and find similar documents using cosine similarity, etc. If it's not clear, we are just going to see that, so don't worry. Similarly, you can summarize documents and you can do classification of documents into positive or negative. We are going to just see summarization of documents as well. Now let's run this cell. So what does this cell do? Essentially, we are getting all the words that are present across all the documents. And why are we doing that? Simply, if you want to create one unique vector for each movie plot, what you need to do is you need to collect all the unique words. Now they become the features or columns, and now you'll go and fill in only those values that are present in the given movie plot. It will be more clear when we just run this cell. So as you can see, what's happening here is that there are 3379 movie plots, and from each movie plot we calculated the term frequency by splitting it into words, and in total if you take all the words you have 773834 words. But there are a lot of duplicates in that, because that is just the collection of all the words that are present across all the movie plots. Now if you just take all the unique words from there, you are getting 55,045. So how does your TF-IDF vector look like now? So for every movie plot, you are going to get a 55,045 vector. So what's happening here is that you will have almost 55,000 columns. Each unique word from the corpus is a column, and for a given movie like Batman Begins, what you're going to do is calculate the term frequency and only go to those locations where words are present in Batman Begins movie and keep the term frequency values there, and rest of all the values will be 0. And why do we do this? Because no matter whether the movie plot is small or big, we want to have a uniform vector. And how do we get uniform vector? In order to get uniform vector, we need to collect all the unique words across the whole corpus and keep them as the columns. And that's why we got this 55,045 as the number of unique values. That is the vector size that we are going to deal with. And one thing to remember is that since most of the values will be 0, this vector will be a sparse vector. Now let's run the next cell. And what are we doing for this next cell is basically we are also calculating the IDF, because for the whole corpus IDF can be calculated once. And what is exactly IDF is basically you are going to collect for each word how many times that word comes across all the movie plots that we have. That is among 3379 movie plots, how many times a given word comes. And what we are doing here is we are initializing the value by 0. Now in this section, we are just going to collect how many times a given word occurs across all the movie plots. Let's run this. As you can see, Nordstrom only comes in only one movie plot across 3379. But if you take something like straining comes 11 times. So this is intermediate step where we are getting document frequency, not term frequency, but document frequency of the word Nordstrom across the corpus. And how do we get our inverse document frequency? The final one is simply dividing this document frequency and applying all the things, the logarithm and numerator and denominator plus 1 that we have already seen. We can get the value. And as you can see here, we got the inverse document frequency values for the whole corpus. Awesome. We are just showing our data frame here, but nothing too complex. But at the end of the day, the inverse document frequency is calculated once per corpus, because all we are collecting is how many times a given word comes across the movie plots. So we are pre-calculating this inverse document frequency for the corpus and we are saving it. Now what you can do is, you have the term frequency here and you can get the inverse document frequency of Jonathan from here. And for any given movie plot, you can create the TF-ID of matrix. How do you create that? For let's say you have this movie plot Jonathan Rivers. What's going to happen is that you will have all these 55,000 words, XYZ, ABC, all these 55,000 words, let's say, and these 55,000 words will be the columns, and underneath each column, for example, one word could be Jonathan. Let's say instead of XYZ, let's just call it Jonathan. And what we are going to do is that for this movie plot, you are going to get to this TF and unique words, and wherever this word is present, Jonathan, you are going to calculate the TF-IDF, which is 0.03 multiplied by whatever IDF that you get from the above dictionary. You will multiply and get the TF-IDF value and you will fill it here. Similarly, for this movie plot, whatever unique words are there, you are going to fill in those values and the rest of them will be 0. So for every movie plot, there will be one TF-IDF vector that is of 55,000 length. Now the thing is, do you need to manually calculate all these term frequencies and inverse document frequencies every single time? The short answer is no. There are already libraries that are available that will make the task extremely easy for you. You don't need to look at any math or calculating these things. I've just shown you these things so that you are aware of how the calculations are happening behind the scenes. What is term frequency? How do you calculate term frequency of a given word? How do you calculate inverse document frequency of a given word? How do you multiply both of those things to get TF-IDF value? How do you create a unique vector that is of fixed length for each movie plot? In order for you to understand everything intuitively, we have derived those things, but moving further on, we'll use libraries heavily. Don't worry about hand coding these things every single time. Libraries make the task easy for you.